Hi, good day, kids. This is your Year 8 Electronic Module 2.1. All right, and in this module, we're going to learn about draw the graph of the linear function following certain scales and determine when does a point lies on the line, right? So in the first video, we have learned about how to transform this kind of functions into y is equal to mx plus c. Okay, so let's try to. We have learned from the first video that from the first module that we have 2x plus y is equal to 5 and the y is equal to negative 2x plus 5, right? Now, linear functions. When you say linear functions, let's talk first about functions. When you say about functions, it means y is dependent or x is dependent on y. Or the best way to look at it is you can think of it as a function machine, wherein this you input x, and then the output, that's the input, and then the output is y after it follows a certain rule. Now, what is the rule? The rule is this one. The rule follows this, negative 2x plus 5. What do you mean by the input? The input is the value of your x, and the output is the value of your y after you inputted the x. So in this question, for example, we have said, what is the value if x is equal to 1? So what we're going to say, if x is equal to 1, you input your 1 here. Once it's inside there, it will be processed according to this rule. It says y is equal to negative 2 times 1 plus 5. Okay? So it means that y is equal to negative 2 plus 5 is equal to 3. So meaning to say, if x is equal to 1, y is equal to 3. Or we can write this one in a coordinate 1, comma 3. Right? So we can input here, that's actually equal to 3. Now, if you're going to do the same thing, right? I think we can now use the function notation. When this is the rule, right? So we can also write that rule as y is equal to the function of x is equal to negative 2x plus 5. Why function of x? Why function of x? Because this is in terms of x, meaning it uses the variable x. Now, if x is equal to 1.5, meaning to say your function of 1.5, you plug in the 1.5 inside, that will be negative 2 times 1.5 plus 5. And this one will give you negative 2 times 1.5 is negative 3 plus 5 will give you 2. All right, so therefore this one now is 2. Let's put there 2. And the last one, maybe you can try this by yourself. You can pause the video while you try that by yourself and then try to check your work if you would like to. So you have negative 2 times 2 plus 5 is negative 4 plus 5 is equal to 1. Okay, so that's it. So this is now 1. Okay, so by the way, we can write this one as 1.5 comma 2, and this is 2 comma 1. right? Meaning to say, guys, these points, this 2 comma 1, negative 1.5 comma 2, and you have here the 1 comma 3, meaning all of them satisfies your function. Now, what does it mean when it satisfies the function? Let's see. But before we go to what does it mean when it satisfies the function, we can draw the graph of this one, okay? To draw the graph of this, then, all right, to draw the graph of that, then we are going to, what do you call this one? Locate the point one by one. So if you forgot how to do it, let me just teach you on how to do it. 1, 3, meaning to say, if x is 1, 1 going to the right, and you move 3 going up, right? And then if you have 1.5, if x is 1.5, you go 1.5 to the left, and after that to go up. And then if, for example, you have x is equal to 2 to the right, and you go up 1 unit because it's 2, 1. All right, and then after that, what you need to do is to draw the line. That's it. So therefore, as we can see from here, the graph of 2x plus y is equal to 5 is a line. Okay, that's why this one is called linear function. It's linear function because it is a function that will give you a line, that will give you a graph, which is a line. And then we have said that the points 1, comma 3, 1.5, comma 2, 2, comma 1 are points on the line. Are points on, don't forget, the line. Okay, they are points on the line. So to satisfy, to check whether a point is on the line, therefore, reversing it, to satisfy whether the point is on the line, we'll just plug in 1 and 3 and it must satisfy the function. Example, if you want to check 1, 3, diba? Oh, sorry. We have said that 1, 3 is on the line. So just to check, 2 times 1 plus 3, is it equal to 5? As you can see, 5 is equal to 5, right? So therefore, really this 1, 3 is on the line. Why is it on the line? Because it satisfies the function. Okay? So let's proceed to the next example before you do the task. Let's try to look at this example. Let me just erase this stuff with my annotation. So it says here, consider the equation negative 3x plus 2y is equal to 12. So negative 3x plus 2y is equal to 12. You have there the values of x, complete, copy, and complete the table. Okay, just copy and complete the table. So let's do it one by one because it is being asked us to copy the table and you complete it later on. All right. Now, on a sheet of graph paper, draw the graph of negative 3x plus 2y equals 12 for x is negative 4 to 2. Using a scale 1 cm to represent 1 unit on each axis. So let's do this one later on. Let's just complete this one for a while. Again, what shall we do to complete? Let us rewrite this into the form of y is equal to mx plus c. And for us to be able to write that one, then we have 2y is equal to 3x plus 12. So you divide by 2 all of them. So you have there y is equal to 3 over 2 x plus 6. And then now we can plug in this one. So if x is negative 4, if x is negative 4, so y will be equal to 3 over 2 times negative 4 plus 6. So that's y is equal to, cancel this one, that's negative 2, negative 6 plus 6 equals to 0. So therefore, if y is equal, if x equals negative 4, that will be equal to 0. Then let's do the same thing for x is equal to negative 1. Okay? You can pause the video if you want to try it by yourself and then check your work. Okay? Check your work after you do it or after you try it by yourself. So this is now negative 3 over 2 or negative 1.5, right? Let's say negative 1.5 plus 6, and that will give you 4.5. So now let's put it there. If x is negative 1, that's 4.5 or 9 out of 2. And then the last one, if x is equal to 0, I think that's a bit, no. The second to the last one, if x is equal to 0, again, you can try to pause the video if you would like to try it by yourself. All right, so y is equal to 0 plus 6 and y is equal to 6. So now you put there 6 and the last one, if x is equal to 2. If x is equal to 2, 3 over 2 times 2 plus 6, y is equal to 3 plus 6, y is equal to 9. So there, sorry, y is equal to 9, right? So now we're going to draw all of this, 0, 4.5, 6, and 9. Now, what is the meaning of the next question? The next question says, on a sheet of graph paper, draw the graph of negative 3x plus 2y equals 12 up to x negative 4 from negative 4 to 2 using a scale. This is important now because it has a scale. What does it mean? You know, in your graphing paper, there's actually grid of lines, right? Normally in your graphing paper, this is 1 centimeter. One of these is 1 centimeter. So basically, what am I trying to say? Each block like that is 1 cm by 1 cm. So this is 1 square cm, the area of this. So it says there 1 cm to represent each unit. Okay? Meaning to say every one of this, like this one, every one of this is 1, 2, because it says 1 cm to represent each one unit. So every one unit is 1 cm. Okay, hopefully that is clear, huh? Next, from negative 4 to 2, meaning to say only the values of x from negative 4 until negative 2. So you don't need to consider values to the left of negative 4 and to the right of 2. Okay? Hopefully that one is clear. Now, then how shall we draw the graph? So we have said before that we can just simply draw and locate the graph one by one. So I'll show you. So this one here is the GeoGebra Classic. Okay, that's the GeoGebra, the one that you can see. So what we would like to do is to draw the graph, right? So we need to locate the point one by one. The first one we have said negative 4, 0 when you look at the table. Okay, the table that we have just did. Negative 1, and 4.5. That's actually this one. Okay, then 0, 6, 0, 6, that's that one, and 2, 9. So you have, if x is 2, oh, it's here, but I did not show it anymore. No, I have shown it actually, but then how can I remove this one again? Hold on. Let me just try to remove this. There you go. So let me just try to remove the, yeah, that's it, see? So maybe I need to make it. Okay, so I think that's better. So 2, 9, the 2 is here, the 2 is here. If it's not yet visible, there you go. I think that's visible now. All right, so from -4 up to 2, okay? Then now you just simply draw the line or locate the line, and that's it. Now, in this one, I would like you to look at the following points. So this one here is your y-intercept. Let me just annotate that with the heart. Okay, that is your y-intercept. And as you can see in our function, we have said that this one is in the form of, remember our this function here, we rewrite as y is equal to 3/2 x plus 6. So guys, this plus 6 is that y-intercept. Hopefully that one is clear. Where can we find the 3 out of 2? Meaning to say that is the gradient, okay? That is actually this one. Remember in your year 7, this is the run. That is the run. And this one here is your, sorry, that is the rise. What did I do? Oh, I'm thinking of rise. So that is the rise here, R-I-S-E. And this is now your run. Okay, that's the run. So as you can see, it says 3 out of 2. But how long is that? That is 6 units. From 0 all the way to 6. And this is from 0 all the way to -4. Right? All the way to -4. So this one here now is actually 4 unit there. 4 unit. Okay? When you simplify that, that's actually 3 out of 2. Okay? That's 3 out of 2. So that is the meaning of this. So again, if this is the given, we transform into slope-intercept form, all right? And then you find out the points, you draw, you locate and draw the line, okay? The 6 represents the y-intercept, meaning the intersection of the line with the y-axis, and this one represents the slope, meaning that is the rise over the run. Okay, so now what I would like you to do now is to do the task number 2. All right, and your task number 2, by the way, let me just clear this one, all of this. So that is now, we have learned from this, the graph of the equation is a straight line, and the solution are the coordinates of all the points on the straight line. Okay, so are you ready for the task number 2? Okay, let me just pull it up. All right, so this is your task number 2. Number 1, question number 1, in each case, determine whether the given ordered pair is a solution of the equation. All right, again, what did we say? You plug in this into each function, and then if it's true, then it is a solution. Okay, in here number 2, just exactly follow the same the same stuff that we did. Oh, by the way, I forgot to answer there's still one more question. Yeah, this one. The point negative 2p lies on the graph. Use the graph to find the value of t. So you have an option, no? Just plug in x equals negative 2 to the function a while ago in here to this function that we did. But it says here, use your graph. So what we're gonna do is we can use the graph of x equals negative 2. So how shall we do that one? So if that is the function that you have, okay, all you just need to do is to locate x equals negative 2. So x equals negative 2 is here, and then just go up. So the answer now is that. So if x is equal to negative 2, then that p is equal to 3. Okay, so that's all for this video. Hope that you've learned something. The next module is 2.2. All right, hope you enjoy. Have a good day and goodbye.